Dear students, for today we'll see what do we mean by sampling process. So let's see the sampling process. Now here, the main thing to understand is sampling process is the first step when we want to convert an analog signal into digital. Say for example, you want to convert this analog signal into digital, then first you have to take samples of this. That means you will get samples of the signal like this. See, these are the samples at a specific sampling rate, that is number of samples per second. We are going to have this samples. So this will be your sampling process, that you are going to convert a analog signal into discrete samples. So this is your analog signal and these are your samples of those signal. Okay. Now this will be the first step, sampling. Okay, and in that you have some theorem called as sampling theorem, where we have to see that the sampling rate is at a particular value so that you can reconstruct the signal back. Okay, so here after sampling, one more process is there which is called as quantization, which will give a standard value to this amplitudes of each pulse, and then that standard value, say for example 2 volt or 3 volt, that standard value will be converted to binary number like 0010 or 0011, like this. So that process will be called as quantization, and you are encoding to binary bits. Okay, so sampling plus quantization are the two steps by which you can convert analog signal to digital. Okay, so sampling process is the first step where we are going to get samples out of that continuous time signal. So here, sampling process is something where a continuous signal is converted to discrete signal by a process called sampling. Sampling is the process in which the amplitude of a continuous time signal is measured at discrete instants. Sampling converts continuous time signal to a discrete time signal. So all these concepts can define us what is sampling process. So sampling process, if you take the definition correctly, then we can say that sampling is the process of converting analog signal into a discrete signal or making an analog or continuous signal to occur at a particular interval of time. This phenomena is known as sampling. So from a continuous signal, you have converted that continuous signal into samples. Okay. Then we'll go to see what is the basic circuit by which you can generate samples. Okay, basic circuit we'll see. Now we'll see a simple circuit by which you can do sampling process. So let's have an input here. So let's give an input. Input is given here. Okay, and here you can have a electronic switch, a simple switch whose position number 1 will be here and position number 2 will be here, and this will be your electronic switch which can go like this, and from here you can connect it to output. Here you can take your common point. Here you can have your input to be given, and here you can note down your output. So this is point number 1 and point number 2. Okay, so this is your electronic switch. Just a simple switch you can take, electronic switch, and here you can show your input signal xt. You can show here. Now that can be an analog signal. Say this is your analog signal. Say this is your analog signal, whatever you are going to have with respect to time, 0 amplitude. Okay, you're having analog signal, and here output will be your sampled signal, which you can take it as XST, which you can show it like this. Say you're having this, and so this is the envelope of the wave. This is time, and you will get samples. You will get samples at the output. Okay, you will get samples at the output. And how many samples per second is there? For that, you will be having a rate. Now, this time period between the two pulses will give you time period Ts. Now, sampling frequency Fs will be equal to 1 upon Ts, and that is the rate what you're going to what you're going to use. Now, what is happening here? Whenever the electronic switch, whatever you have shown here, is at position 1, is at position 1, at that time, whatever input you have will pass to the output, will pass to the output. And whenever this switch is at position 2 here, the input is stopped from passing to the output. Okay. Now this switch will change its position from position 1 to 2, again 1, 2, 1, 2, 1, 2. It will go on switching its position. Now, if that rate of switching is equal to your sampling rate Fs, okay, then you will get like this samples at the output. This is the output. You will get like this samples of the output. So this input, which was an analog signal, which was a continuous time signal, is converted into discrete samples by such a circuit. A simple circuit is shown here, which will have a electronic switch, and that switch will change its position from position 1 to position 2 and position 2 to position 1 for a specific time periods depending upon the sampling frequency, and depending upon that particular part of that voltage or that of that a continuous signal will be passed at the output. Say for example, here you are having this continuous signal and you switch on here at position 1. Okay, then you will get output pulse like this here, and you switch at position 2 here, then the output pulse will be like this. Again, when you come to position 1, again you will have output pulse. Again you come to position 2, then your pulse will be like this. So like this you are going to get pulses by switching the electronic switch from position 1 to 2 and again back to 1, again to 2, in that way. But only thing, that switching frequency should be equal to your sampling frequency, means how many samples you want at the output. Clear? The sampling process can be implemented in several ways, but the most popular being is the sample and hold circuit. So there is a circuit called as sample and hold, which is more importantly used, or it is used popularly to convert samples from an analog signal. Now, what is this sample and hold circuit? A sample and hold circuit is capable of sampling the input signal applied to its terminal, as well as holding the sampled value up to the last sample for a particular time interval, known as sample and hold circuit. It utilizes an analog switch and a capacitor to perform the task. So here, if I have to draw a sample and hold circuit, say you want to draw a sample and hold circuit, hold circuit, then you can show the input you can give to a unity gain amplifier. First, here you can have an amplifier. Unity gain, it is so that no loading effect takes place ahead. Then you can give this input to a switch, and after the switch across you can have a capacitor. You can have a capacitor, and then from here you can take the output. You can take the output. So you can join this, you can join this, and you can join this. Okay, so here you are going to give the input. Input is given here. Then this is your analog input. Okay, And then you are having an amplifier which is a unity gain amplifier. Unity gain. That is, it is not doing any amplification process as such, but it will see that the input and output are loading effect is minimized. It avoids loading effect due to high input impedance and low output impedance. It is acting as a buffer. It will avoid loading effect. Then here you will be having a electronic switch. This is your electronic switch, which will be on and off positions. It will go to on and off positions. Now it is open. You can close it. Again, you can open it. And this is a capacitor C here. Okay, and here you can have a output. Okay. Now here, sample and hold circuit is shown, and this circuit consists of three units. One is unity gain amplifier, second is switch, and third is capacitor. Okay. Now the a unity gain amplifier is acting as a buffer due to high input impedance and low output impedance. It avoids loading effect. The electronic switch is timed to close only for a small duration. During this period, when the electronic switch is closed, during that period, a capacitor charges up to a voltage level equal to that of input sample. Equal to that of input sample. Means if you show with a waveform here, say if this was your input, you can show an input here. If this was your input, okay. Now at one time interval, you are closing the switch. If you close the switch, the capacitor voltage will reach the given amplitude. That instant, what is the amplitude of the analog signal? It will reach there. Okay. And when you open the switch, the capacitor will retain that value till you again next time close the switch. And once you close the switch, it will go to the next value, whatever the amplitude is going to give at that time of the input signal. Again, you open the switch, it will retain the value. Again, if you close the switch, it will reach to the next value. Okay. And it will retain that. Again, if you open, it will come back. Okay. Again, it will go to the next value. So here you can see it will go to the next value. Then it will retain that. Again, it will go to the next value. It will retain that. Again, this will go. Okay, so this process will go on. This process will go on. Now, in this way, what has happened? The capacitor retains the voltage level until the next closure of the switch. So once the switch is closed, it will attain a level, voltage level. And when the switch is open, it will retain that until the switch is again closed. Thus, the sample and hold circuit generates a pulse amplitude modulated waveform, a staircase waveform. This will be like a staircase waveform. Staircase waveform. This can be called as pulse amplitude modulated waveform. Okay. And this can be generated at the end of your sample and hold circuit. That means you are generating samples at regular intervals. Okay. You are generating samples at regular intervals. That means you're converting a continuous wave signal into your discrete samples, discrete interval samples. Clear? This is what the sample and hold circuit is used for. Then diagrammatically I have shown here the sample and hold circuit. Whatever we used will be here. So this will be a sample and hold circuit in which you will be having amplifier, electronic switch, and a capacitor in parallel. This will be your input. This will be input, and you are going to on off the switch depending upon the command like this. This will be a sampling rate, on and off of switch. Okay, on and off of switch, and this is what output you will be getting. Output you will be getting as a staircase wave, and every time a capacitor is closed, it will take the value of the analog signal at that instant, and when it is open, it will retain that value for some time. Again, when it is closed, it will take the next value. Again, when it is returned uh, open, it can retain the value. In this way, you will get a staircase waveform at the output, and this staircase waveform will be nothing but the samples of the input continuous signal. So in this way, sample and hold circuit converts a continuous wave into a samples at discrete intervals. What are the advantages of sample and hold circuit? Number one, it provides synchronization to all the channel present in multi-channel analog to digital converter. So it is useful in synchronization timing. Second one is the possibility of crosstalk can be reduced by using sample and hold circuit. Okay. Then what are the applications of sample and hold circuit? Sample and hold circuit have many applications, few of them named here. Number one, they can be used in ADCs, analog to digital converters. They can be used in DACs, digital to analog conversion. They can be used in analog demultiplexing, in linear systems, in data distribution system, in a digital voltmeter, in signal construction filters, and many applications are there which you can name as applications of sample and hold circuit. Thank you, students.